Hello, everybody, and welcome back to Track 3 Cloud of Python WebConf 2021. I believe this is day 4 now. It's crazy. I think I lose track of time with these half days. My name is Josh Qualls, and I am the Loudstorm account manager here at 6 Feet Up. And I am joined by Angel Rivera to talk about CI/CD, agility, and controlling pipeline sprawl.
Want to welcome everyone to this talk. This is a talk I built regarding some of the struggles that we all have, especially, excuse me, within CI/CD. Before we get started, my name is Angel Rivera, developer advocate for Circle CI. And in my role as a developer advocate, I'm generally out speaking, obviously pre-COVID pandemic, obviously out speaking at conferences, engaging the developer community at a grassroots level. And what I'm primarily interested in is learning how people are using technologies and also some of the struggles that they're having with said technologies. It's a pretty good role. I've been with the company, it'll be my 3rd year soon. Just again, I'm interested in learning how people are using technology, some of the wins and some of the struggles that you're having. And then I'm also very interested in bringing that information back to our teams at Circle CI so that we can build bigger, better, faster, more valuable products that our developers and customers find useful. So if you want to reach out to me after this talk, my Twitter handle is the best way to get a hold of me. So my Twitter handle is @punkdata, and I'm open to any and all conversations. Just reach out if you have any questions or just want to chat. This talk, I based it on a lot of the conversations that I had with folks regarding CI/CD, and more in particular around some of the struggles that they're having when managing their pipelines at scale, right? And what I mean by this is, when we're managing our pipelines, when we start building pipelines, they usually start on projects, right? And they're pretty small, right? The automation that you're doing or the commands that you're executing on that new repository is probably, very minimal, right? You're probably testing code. You're probably, running some compliancy checks, some security checks, but overall, the pipelines, are pretty small for a project, or at least they don't do very much. As that project grows, right, as we get more team members on it, as there's more collaboration around that code, the execution of your pipelines and the stuff that you're executing within those pipelines actually starts to grow, right? So, and that tends to lead to issues, right, regarding managing pipelines at scale. Not only do you have that one repo, you probably have 10, 20, 30, maybe hundreds, maybe thousands of repos that you're managing, right? So this talk is geared towards kind of managing pipelines at scale. And again, talking about CI/CD tooling and some of the obstacles that folks are having. And again, these topics that I'm talking about are driven by conversation as well as my own experience with CI/CD. So let's talk about agility. As developers, right, we're supposed to be very fast at producing code changes or releases. It's just kind of becoming more and more standard that release cycles are, multiple times a day or a week, versus months and years, like back in the day when we used to release software. With that added pressure, obviously we have to be agile. And so I like to kind of show definitions of words to kind of remind myself as well of the meanings of these words and kind of put them in context. So real quick, this is the definition of agility, right? Which is pretty interesting to me because it's essentially the ability to move quickly and easily. Now, we are all in DevOps, right? Or at least probably most of us are. And that's great that, agility, the word agility exists, but I think there is a purpose for, smashing these two words together within CI/CD and smashing CI/CD and agility together. And I like to add context to definitions. So I kind of created this term so that kind of put some context around agility when we're talking about DevOps. So the definition I came up with for CI/CD agility is the ability to move continuously, quickly, and easily, right? So it just literally added the word continuously, since that's kind of what the whole point of continuous integration and continuous deployment is. So now that we've kind of framed CI/CD agility, I'm going to talk about some of the two kind of themes throughout in my topics. One is pipeline optimization, and the other one's going to be pipeline sprawl. Now, if you don't understand what either of these mean, it's okay. Pipeline sprawl, especially, I kind of coined that phrase or made it up, but I'll get into that a little bit later in the presentation. So pipeline optimizations, the things I want to talk about are going to be resource classes, or probably better known as compute nodes or executors for your pipelines. Then I'm going to discuss concurrent jobs, caching, and then selective job processing. So with resource classes, one of the things that I see folks struggling with in their pipelines is the fact that they don't appropriately size or give their compute nodes in their CI/CD tooling the proper capacities, meaning they don't have enough RAM, they don't have enough CPU in some cases, and in some cases they don't even have GPUs, right? So that's kind of a new addition to cloud computing, which is like they're offering, or it's a newer addition to cloud computing, where companies are now offering compute nodes that have GPUs associated with them, which are really handy if you're doing any kind of AI type processing. So anyway, let's jump into, again, resource classes, right? So one of the biggest problems that people have is that, right, they're not adequately sized. They don't have, enough capacity. And by the way, this is a problem that can easily solve a good portion of issues that folks are having, especially if their pipelines start to become slower, right? So if their build times are becoming longer, resourcing your compute nodes could help with that, right? It's a small tweak that doesn't take much effort, but some people have a fear of increasing the size of compute nodes because it might cost them a little bit more money. And I can tell you that might be true, but the total cost of implementing a faster build, you have to remember the total cost could actually be cheaper, right, than sticking with that old inadequate compute node. And the reason is the jobs execute faster on those compute nodes. And I've actually done some of my own benchmarking. But you also have to think about the developer's time, which a lot of companies and organizations don't really do that, right? They don't factor that developer's time waiting for builds to finish in that total cost of that compute node. So when you're factoring, those costs, definitely look into how much time the developer's sitting around. And I'm not saying we all sit around, but I generally do. I like to get a coffee and have a sip of coffee or a beverage while I'm waiting for my builds to complete. Now, if we have, these builds executing faster, then we shorten that build duration time, meaning, the developer can focus in on what matters and then fix the problems when they come up in their build processes. But again, just tweaking that pipeline to include a larger compute node with more resources will definitely help, with executing your builds faster and lessening that build duration time. So again, when we're talking about resource classes, make sure that your pipelines have appropriately sized compute nodes. And I won't belabor this point any longer. So another kind of performance optimization folks can do is running concurrent jobs. What I mean by that is running all of your build jobs in parallel where you can. In some cases, we need some dependencies on our jobs. And what I mean by dependencies are, right, if you're, let's say, deploying a a Docker image to Docker Hub, you need to build that image first, right? So obviously you have to build the image to then deploy it. That's what I mean by dependencies. But in most cases, you can get rid of almost every dependency unless there's a legit need to create that dependency. And the reason I say this is because dependencies are blockers, right? So anytime you have to wait for a previous job to finish before executing the next job in your pipeline, again, that's a blocker in my mind, right? So keep that in mind when you're building out your pipeline segments and your jobs. Ensure that you're verifying that if you have any job dependencies, make sure that you really need to have those jobs being dependent, right? I know a lot of folks like to test software before they actually build any artifacts. I'm totally against that. I think we can test software, and if it fails, it will fail the pipeline. And while you're testing that software, you could be building a Docker image. You could be building clusters if you're going to deploy to them, right? So like you can do multiple things at the same time to increase the speed and the velocity of your pipelines. And again, right, even if those tests fail or something's wrong with the image, doesn't mean you have to deploy it, right? So, just be a little bit more thoughtful about how you're creating dependencies within your pipelines. Caching is a really big place where you can actually save and optimize your pipelines. And what I mean by caching is, caching dependencies within your applications. I'll take an example, like Node.js is a good example where, you have those NPM modules that you kind of have to download every time. I would say, cache all of those things and leverage cache if your CI/CD tooling provides caching mechanisms, which I think most of them do. But I would also caution you to be very careful about how you're caching things. So cache cautiously. The reason why I say that is, just because there's caching mechanisms in a CI/CD platform doesn't mean they're being used properly. I've seen, a few folks that I personally know, kind of misuse or not use the caching mechanisms optimally, and they basically have been caching all the things, right, instead of just updating the things that have changed, right? So the strategy when you're caching is, the whole point of it is, to avoid downloading all the things. But, caching allows you to do that if you tell it to. So my advice here is to update the change dependencies only, or the things that have been updated, and don't update the things that don't need to be updated, right? So don't update all the things, just the things that need to be updated. Now let's talk about selective job processing. This is a little bit more of a deeper, I guess, conversation. But one of the things, I think I mentioned it already, is test execution. When you're, planning out your pipelines and the segments within those pipelines and your jobs, again, ensure that you run the things that need to be run. And what I mean by that is in the test execution context is, avoid running extraneous end-to-end tests. Like some people run their whole test suite in the initial stages of their CI process or software development process. That doesn't need to be done, right? So if it's a developer developing some new functionality, you don't need to run all of your end-to-end tests, all of your comprehensive tests that are, take a lot of time. They're very, expensive in some cases, right? They use a lot of compute. They use, they just take a long time to process. Try to scale those back to the tests that you only need to run in the context of your pipeline. So again, if you're in a development mode, you really should only be running, in my opinion, a unit test, some quick focused tests to test the functionality that you're building. And then if that those changes get promoted into a staging segment of your pipeline, then you can run a little bit more extensive tests, right? Because the developer will kind of be will not be totally involved in that for the promotions of those releases unless there's issues. So again, keep an eye on your test executions and ensure that you're running only the tests that need to be run, right? And don't basically run tests in overkill. Conditional job execution is kind of similar to what I was explaining about the test. Understand your CI/CD pipeline segments. So what that means is you have to tie that to your software development process and understand the context of your CI/CD pipelines. So again, if you're a developer and you're kind of developing this functionality as a new piece of code, ensure that you're only executing the things that need to be executed and not burning a lot of compute or time on the things that really don't matter or can be, shifted right down the pipeline to an appropriate segment of your software development lifecycle. And I'll say this as well. This is a piece of advice that I give everyone is, when we're building our software, we tend to start watching how long builds take, right? So specific jobs, or even the whole pipeline. What I would recommend to everyone to be, to have an optimized pipeline or become efficient with your pipelines is set target build durations. So what I mean by that is if you have let's say a Docker build job, right? You're building a Docker image based off of your Docker file or some process in your pipeline. You can set a build duration target, which is a goal, right? It's nothing that's hard set. But like I like to use, for example, a 1 minute, 60-second rule. So I want to see all of my build jobs running within and completing within 60 seconds. Now, I know this is completely unrealistic, but that's not the point. The point is that I have a goal of 60 seconds. And if my builds are going over that 60 seconds, goal, then I'm going to, have a mental note in my head that, okay, this is not within the rule, right? The 60-second rule. Why? And it kind of keeps me in check, right? Like, so it kind of reminds me that, hey, you need to check on this. Now, I know that a Docker build could take way longer than 60 seconds. And in most cases, it probably does. And that's okay. But at least I know, right, why. And if I see, if my Docker build is going at 100 and let's say it's a minute and or maybe 2 minutes, right? But it starts creeping up to like 3 minutes, 4 minutes. That's just the flag for me, right? So my 60-second rule is busted. Why is this build duration longer? Again, it's just something that I like to tell people to kind of keep in mind, is just setting a goal and then understanding when your goals are not met. And of course, you can make a waiver for the things that don't fit in your target environment or your target duration. But again, it's just a goal. So, keep that in mind when you're building pipelines and you're monitoring your pipelines, because once those build durations start, growing and becoming longer, it's going to impact your release cycles, which will then impact a bunch of other things in your software development process. So if you want to learn a little more about, optimizations and some of the benchmarking that we at Circle CI have done on our teams and the folks that are building software on our platform, go ahead and check out this report. It's pretty interesting. It kind of helps you understand how to benchmark a CI/CD pipeline, and then also gives you some ideas on how you could actually implement your own benchmarks, right, based off of your own situation. So yeah, I really advise everyone to kind of check that report out if you get a chance. It's pretty interesting stuff. And if you're interested in improving the velocity of your team and release cycles and the mean time to recovery for your builds, definitely give this a look. So let's do a quick recap on pipeline optimizations, right? I talked about resource classes, adequately sizing your compute nodes so that you can have a pretty lean, mean, fast pipeline, and everything's executing, at a reasonable manner, a reasonable time. Obviously, right, there might be some increase in costs, but they can be generally offset by the faster execution, which means that the build will run less, so that cost might even be lower, and also only use what you need, right? With job concurrency, just what that means is run everything you can, all your jobs in your CI/CD pipelines in parallel, and of course avoid any build job dependencies wherever you can. Caching, right? The thing here is just update the things that have changed. Don't update all the things. That's the simplest advice I can give you. And then selective job processing, right? Similar to the advice I gave you before, just run the test that you need to run in the context that you're running within your CI/CD pipeline. And also, evaluate the jobs that you're executing in your pipelines and ensure that they are, again, in the appropriate context of your pipeline and your software development lifecycle. So now that I've covered all of that and pipeline optimizations, let's go ahead and talk about pipeline sprawl, which is, I'm sure all of you are interested in learning a little bit more about. So with pipeline sprawl, most CI/CD platforms today, modern CI/CD platforms today, operate pretty much in this context where you define your CI/CD pipelines in a configuration file, right? And generally speaking, and again, this is a general ratio or general math. I understand that other folks, this may not apply to other folks, but in general, the people that I have conversed with and the people I deal with generally run or maintain their code in this manner: one code repository per one pipeline configuration file, right? So the ratio is 1-to-1, one repo, one pipeline configuration file. Now, those configuration files are generally, the syntax within them, right, is basically YAML. And unfortunately, folks are misinterpreting what YAML really is. And when they're building these configuration pipelines, they're generally using YAML inappropriately or viewing it as inappropriately. YAML is not a programming language, right? YAML is actually a data structure. And it's on the same vein as like a JSON, but obviously the syntax is different, completely different, but it still is a data structure, right? Human readable data structure. And what happens with YAML is the syntax within those configuration files within YAML can be redundant because of the way, or because of the context that we're using the YAML. Essentially, what we're doing with that YAML is declaring and defining commands that will be executed in our CI/CD pipelines, right? The problem with YAML is it doesn't have a lot of mechanisms for repeatability. It has like one thing called an anchor, and it's not very helpful when you have a lot of functionality going on, especially in that YAML data definition. So what happens with those configuration files in YAML is that the syntax begins to grow in complexity, in length, right, and in volume. So like you're adding many, many lines of code to your YAML, and it becomes really, really hard to navigate and manage, right? So it's just like any other piece of code. The more of it that you have, the harder it becomes to navigate and manage. So when we're talking about the configuration file being sprawling, we can also have that same situation with configuration repositories, or I should say code repositories, not configuration, but code repositories. So it's kind of the same problem, right? Your config file gets really long, has a lot of volume, a lot of syntax, and then you could also have the situation where you have those long config files, and then also many repos, right? Like thousands of repos. They become also difficult to manage. So we're managing these configuration and repo dilemmas, right, that we have at scale. I've actually spoke to a few folks and trying to solve some of these problems, and we looked at GitOps, some of that concept to try to help. But the GitOps, the GitOps mechanism doesn't really help in this situation. It's not a viable solution because of the way that GitOps is basically, your code is a source of truth. But if you have multiple sources of truth, right, how do you manage that at scale? One of the things that I can tell you is that you don't want to be hard coding commands into your pipelines or into your CI/CD configuration files. And this is a good example of a hard coded kind of command that I've lifted out of one of my configuration files out of a pipeline. which is essentially uploading, right, an artifact to an S3 bucket. As you can see, though, right, I'm defining all of the things, the functionality, as a hard code, right? So the app name, I'm sorry, the artifact name is hard coded. The bucket that I'm uploading to is hard coded, right, in that command. If you have like that command maybe 10 times in 1,000 different repositories, that means you probably have 1,000 different config files, and now you have to update those 10 commands and all of those 1,000 config files, right, a bunch of times manually, obviously, right? That's going to take a long time. Even if you automate that, you still have to automate the automation to validate your validations, right? So you go down a huge rabbit hole. Trust me, I've tried. It doesn't work. So like you're probably asking yourself, okay, so what are my options here, right? So when I started looking at this problem and solutions for this problem, I kind of put my developer hat on and tackled it as a developer. And it immediately became clear to me that this is basically a problem separation of concerns. So if you follow object-oriented programming patterns or concepts, the first thing you want to do is identify the common pipeline patterns, the things that are occurring within your pipeline and configuration files repeatedly, right? And once you have those identified, you can create abstractions, right? So you can now group that functionality into specific encapsulations, right? So you can create a pattern that's repeatable, and then create the parameters and you can parameterize those values and properties so that you can then create reusable patterns of code, right? So it's, again, no different than any OOP strategy, right? Create an abstraction, encapsulate that functionality, and then create these parameters within that functionality so that you can create reusable modules. So what I'm proposing here is, if you probably haven't figured it out yet, is the creation of pipeline libraries, right? Store your functionality separate from your configuration file. Now, this is what I mean, or this is an example of something that is a reusable piece of code, right? And it's the same example I used earlier about hard coding. As you can see, it's the same command, but what I've done is I created a script, right, that abstracted and encapsulates the functionality that I want to do, which is the upload of an S3 bucket, or upload of an artifact to an S3 bucket, right? And as you can see, I've created some arguments that are for the file and then also for the AWS bucket. So having this command in this form basically, eliminates that hard-coded command and then gives me the ability to update all of my configuration files with this specific command, right? And then I can use variables to control what the values are that are fed into that script. And when you have that pipelines library, you also are doing a few things, which is basically centrally managing or creating functionality that's centrally managed. So all of those files could live in that library. And then when you make that one change to one of those library files, your scripts, you're able to then propagate that change across the board to all of your pipelines without having to do much work, right? So those are the benefits of kind of encapsulating that functionality, and then also controlling that pipeline sprawl. Also just adds portability, right? So you can take that same script library and then apply it to other projects if you want, or use that same script library in other projects, however you would like to do it. But again, it adds a lot of portability. And then, one of the other side effects of this is you're minimizing the vendor lock-in, right? All software we use, we're locked in at some point to some degree, but this will minimize that type of vendor lock-in that you have, because if you can, take those scripts, and if let's say you're rip and replacing your CI/CD tool, you have those scripts that are abstracted away from that vendor lock-in, which is that hard coding. And then you'll be able to easily implement this new technology or new CI/CD platform, because you have that functionality extracted. It should be a lot simpler, a lot easier to implement in this new tool. So we did this at Circle CI. We actually created orbs, which is essentially packaged up reusable functionality, right? So people are writing like the S3 upload. We have an AWS CLI orb, which essentially gives the ability for the user to just call on our orb, which is code that we've written and maintained in our orbs registry, right? So again, that centrally managed place, right, for the code. And then it's easily implementable in your configuration files. So with orbs, we're helping our developers kind of break free from all that hard coding and just deal with the problems that they need to deal with, which are, their code, and not worry about the implementing functionality, right? You can just call it off the shelf kind of thing and import it into their pipelines really easily. So real quick, let's recap. I know I'm running out of time here. Let's recap the pipeline sprawl. Again, identify your common patterns within your pipelines, encapsulate any functionality that can be encapsulated into parameterized scripts, and then use those scripts to consolidate and centrally manage the code and the functionality that you've written, right? That you want to execute within your pipelines. And then again, right, the scripts will help you to add some portability into your processes and also minimize that vendor lock-in that we all really, really love. I'm saying that sarcastically, but yeah. So once again, I just wanted to call out that, if you want to learn a little bit more about how to run your teams a little bit more optimally or benchmark your CI/CD processes, check out the State of Software Delivery report at this link. And I think that is all. Yeah, that's it. So thank you for attending. I hope this was useful. If you want to reach out to me, I will be, I guess, having conversations and taking some questions after this. But @punkdata is my Twitter handle, and I look forward to speaking to all of you. Thank you.